Okay, shall we move to the next topic? Okay, now write on the next heading, that is what? Spring combination. Now what we are going to learn is what? Multiple spring system. Okay, and that is what? Spring combination. Now, in the earlier today class, what we are learning, there is a one spring, and that one spring is having what? Two free ends. Those two free ends are either been connected with two different masses, or one end is what connected with what? Fixed, and the other end is what connected with what? Some mass. Yes or no? But now what we are going to learn is what? Spring combination. That means there may be two springs or there may be more than two springs. Okay. In simple language, in simple terms, how we are classifying springs are, if springs are connected end to end. If springs are connected like this, end to end. Let's say over here I will make one marking. Over here what we are going to learn, that is what? Series combination. Okay. In series combination, what is happening I will tell you. Over here is series combination, and over here consider that is what? Parallel combination. Okay. In series combination, if two or more springs are being connected like this, end-to-end connection. Okay, if two or more springs are being connected end-to-end, then what we are going to call this as what? Series combination, like this. Connected with some mass. Okay. If two or more springs are being connected like this, parallel to one another, this one is one spring and this one is one spring connected to a mass, like this. Okay. In simple or the basic classification, how we are learning, two springs, spring 1 and spring 2, are connected end to end with a mass, then we are going to call it as what? Series combination. If two or more or many, whatever the value you want to take, if they are parallel to one another, then we are calling this as what? Parallel combination. Simple classification. But in reality, we are not going to define always based on end-to-end connection or based on visibility of parallel. Okay, if two or more springs are looking parallel, then we can say always parallel. We cannot judge like this. Okay. Before that, before starting the topic, let me tell you one thing. How we are defining what? Spring force? According to what? Hooke's law. Yes or no? According to the Hooke's law, we are saying that F is equals to what? Kx. Yes? Okay. And what is the K? K is a spring constant. That means K is not changing of a particular spring. Okay. Only two things are varied. Either the force can be varied or either the displacement can be varied. Or yes or no? So, based on what? Force and based on what? Displacement, we have classified combination of a spring into two groups. One is what? Series combination, the other is what? Parallel. Okay. Now, let us understand like this. Consider over here. Okay. Two springs are there. So, according to what I said already, either according to the force or either according to what? The displacement. Okay. Let us try to understand that. Consider this is your spring 1 and this is your spring 2. Okay. Let's say this one is having a K value. K is equals to, K1 is equals to, let's say 100 Newton per meter. Okay. And K2 is also equal to what? 100 Newton per meter. Both springs are having same spring constant. What do spring constant tells you? About the stiffness. Or yes or no? That means the stiffness of both the springs is same. Similarly, consider spring 1 and spring 2 over here also, and consider this one K1 and K2 both are having again the same value. Okay. Now listen carefully. Two springs, same stiffness. Okay. Let's say I applied some external force on this block and this block reached to a displacement or reached to a distance of 3 meters. Consider here it reached here. Total displacement of the block is what? 3 meters. Now what I am asking is, if this block is being displaced to a distance of 3 meters, then stiffness of this one and stiffness of this one both are same. Then can I say that both will expand with the same amount? Or yes? So why? Because this one K1 and K2 both are having the same value. If both are having the same value, definitely the expansion of each spring will be same. Then can I say that this spring one will expand to a distance of 1.5 meter and this one also expand to a distance of 1.5 meter? Yes or no? Okay. If I calculate the amount of spring force what spring is applying, then can I say that K into X, how much this one is displaced? 1.5. How much this one is displaced? 1.5. Can I say that? Okay. 100 into 1.5. 100 into 1.5. That means, can I say 150 is the spring force. So over here, force of spring 1 is equals to 150 Newton. Can I say that force of spring 2 will also be the same? That is what spring 1 and spring 2 are applying the same amount of force. Are you sure? Both are connected in what? Series. Both are connected in what? Series. Both are having the same stiffness. Okay. Displacement of the object is how much? 3 meter. Yes. Force same. Can I say displacement is also same? So what are the things happening? Because of the stiffness, force is same. The amount of spring force in the both spring is same. Displacement is same. Are yes or no? And total displacement is always equal to what? The displacement of the object. Can I say that? Okay. What is the total displacement of the object? 3 meter. And this one is expanding, let's say 1.5 plus of 1.5, and this one is displacing 3 meter. Are yes or no? Okay. Now come over here. Come in the parallel now. In parallel, I am again saying that K1 and K2 are having both same value. This one is also 100 Newton per meter and this one is also 100 Newton per meter. Okay. Now this object is being again displayed to a distance of, let's say, 3 meter again. So what is the total displacement of over here? 3 meter. Are yes or no? Okay. Now tell me, what will be the amount of force in each spring? What will be the first? Tell me the displacement. If this one is displayed to a distance of 3 meter, can I say this spring 1 will expand to a distance of 3 meter or 1.5? 3 meter. Okay. And spring 2? Both will be, yes, very good. So both will be expanding to a distance of what? X1 and X2 are both same, which is equals to this X. Are yes or no? Over here, X1 and X2 again both are same, but it is not equal to what? X. That is what? 3 meter. So let's say this one is X. This one will be, then can I say that over here, can I say X1 plus of X2 is equals to, then I can say this is equals to X. Are yes or no? Over here, can I say that X1 is equals to X2 which is equals to X? Aaya kya? Over here, what I am saying, the displacement or the expansion of this spring is equal to net displacement. Okay, what is the net displacement? 3 meter. What is the displacement of each spring? 1.5, 1.5. So over here, what I am writing? X1 plus of X2 is equals to X. Yes. Over here, what I am writing? X1 is equals to X2 is equals to X. Are yes or no? Now, the next thing. ये तो समझ में आया what I am trying to say, what is the difference between a series and the parallel. So what is the basic difference? The expansion of the two springs, the sum of the expansion of the two springs or the sum of the compression of those two springs will be equal to the net displacement. Can I say that? Okay. Similarly here, the expansion in each spring will be same, which is equal to what? The net displacement. First point number 1. Okay. If stop writing and if abhi mat likho, if K1 and K2 are not equal, if K1 and K2 are not equal, let's say this one is 200. So what will be the changing value? Now can I say what do first? K1 and K2 again? Stiffness. Yes or no? Which one is having a higher stiffness, K1 or K2? K2 is having the higher stiffness. Let's say again the displacement is what? 3 meter. Again the displacement is what? 3 meter. Now will they expand with the same value or a different value? K1 will expand more or K2 will expand more? K1 will expand more, yes, and K2 will expand less comparison to what? K1. Now let's say K1 expand to a distance of 2 meter. K1 is expanding to a distance of what? 2 meter, and K1, that means spring 2 is expanding to a distance of 1 meter. Then can I say that again X1 plus of X2 is equals to what? 3. That is equals to what? Your X. Can I say that? Achha. Now the next thing what we need to observe carefully, If I multiply, what is spring force again? K into x. So K1 is what? 100. What we are considering the displacement? 2. So 2 into this 100. That means spring force which is from the spring 1. So spring 1 will be applying how much? 200 Newton of force. Can I also say that this one is going with 200 and the displacement is what? 1 meter. Yes or no? So higher the stiffness, less will be the displacement. Lower the stiffness, higher will be the amount of expansion. Yes or no? Okay. So 200 into again this one. Then can I say spring 2 will also apply this force that is equals to what? 200 Newton. Okay. Now, even though if we are not understanding this by some calculation, we can already say that springs are massless. Yes or no? Spring is massless. If massless spring means force must be same. I got my point? Okay. Then second thing, what we need to observe over here, even the expansion is different. Even the expansion is different when they are connected end to end. But what? Force is same. Force along this spring and the force along this spring is same. I got my point? Force is same, but displacement is what? Different. So if force along multiple springs, can I write like this? Multiple spring is same. Is what? Same. Then it is called as what? Series combination. Ye yaad rakho. Okay, the main thing we need to understand how we are classifying. If in a system, the force along multiple spring, in all the spring, the force must and should be same, irrespective of their displacement. One will be having 2 meter, one will be having 1 meter, one will be having 100 meter, whatever the amount of displacement. The sum of expansion or the compression of all the springs must and should be equal to net displacement. I got my point over here. Okay, but in parallel, over here, if I change the value from 100 to 200, 100 to what? 200. Now, expansion will be same. Over here, what is same? Expansion will be same. If I displayed over here and I change the value from 100 to 200, this one is having different value, this one is having now different value. Displacement is 3 meter, na beta? Yes or no? Displacement is 3 meter. That means, can I say that that spring 1 will display to a distance of 3 meter only, spring 2 will always expand with 3 meter only. Both will be expanding to a distance of 3 meter, even though they are having different stiffness. That is what? Spring constants are different. Okay. If I substitute the value and I calculate the force, then spring 1 will apply into 3. This one is also displacing 3 na, x1. So 3 into 100, spring 1 will apply. So force in spring 1 is equals to what? 300 Newton. Are yes or no? 100 over here, displacement of this or expansion of this spring is 3 na. 100 into 3, 300. Similarly, force of spring 2 is also equal to 300, or will it have the different value? Now, this spring is expanding how much? 3 meter. What is the spring constant? 200. So 200 into 3, 600. So amount of spring forces are different here. So what should I write over here? Expansion or the compression. That means displacement of each spring must be same. Must be what? Same. Then what we are going to call this as what? Parallel. Okay. So if the displacement of each spring is same, then that particular setup or the fixation or the combination is called as what? Parallel combination. If force throughout the springs or the multiple springs is what? Same, then we can say that setup is what? Series combination. अरे आया कह रहे क्या और टाइम पास करना है? आया सभी को? Okay. So in series, what will be the same? Force will be same. And in parallel, what will be the same? Displacement is same. Are yes or no? Forces may be different, may be same, but depends on what? Stiffness. Are yes or no? Now, over there, can I say that? Thoda dhyan se suno. Is this statement true or false? Tell me. If stiffness is same, can I say displacement is also same? True or false? True. So, but the net displacement here should be x1 plus x2 is equals to x. Okay. Over here, if even though stiffness is same, the displacement is always equal to the net displacement of the springs. I got my point. So, x1 is equals to x2 is equals to x here. But over here, x1 plus x2 is equals to x. Either spring value or the spring constant is same or different. I got my point. Over here, always remember, if force is same, then that setup is what? Series. If displacement is same throughout the spring, then that setup is what? Parallel. Simple logic. Okay. Now write down. Okay. Shall I? So what is happening in series? Force is same or displacement is same? Force is same, and displacement is equal to, net displacement is equal to sum of displacement of all the springs. Yes or no? So for series, let us try to derive one equation how we are going to calculate the K equivalent. Okay. So why we are going to calculate the K equivalent? Because we are having only single equation now. So F is nothing but equal to Kx. Okay. Either force is same or either the displacement is same. But a particular thing, that is what spring constant for a single spring is same. But now what we are having multiple springs. So multiple springs we need to calculate K equivalent. Either they are connected in series or either they are connected in what? Parallel. You have to recognize that. Based on what? If force is same, they are connected in what? Series. If displacement is same, definitely they are connected in what? Parallel. Are yes or no? In series, just now we learned that x1 plus of x2, which is equals to x. Okay, this is what? The net displacement. This is what? Displacement of what? Or the expansion of first spring or the expansion of the second spring or so on. x3, x4, so on. I got my point. So x1 plus x2 plus x3 plus so on is equals to what? X. I got my point. Okay, now force is same or displacement is same? Here force is same. So in series, force is same. Okay, if force is same, then can I write over here x1? From that equation, can I write like this? X is nothing but F upon K. F upon K. Over here, then can I say F upon K1? Why? Because forces will be same. So F2 or F upon K2. Not F2, F upon K2. Can I write like this? Okay, so on, which is equals to F upon, that is what? K equivalent. I got my point. Okay, from here, F get cancelled out. So K equivalent is nothing but 1 upon K1 plus 1 upon K2. You need to use this equation to calculate what? K equivalent if they are connected in what? Series. I got my point. Similarly, if they are connected in what? Parallel, then we need one more equation. So for parallel, what will be the same? Displacement will be the same now. So X is same. So if X is same, then what will be different? Force will be different. Are yes or no? So can I write like this? F1 plus of F2, which is equals to F. Are yes? And what is F? K1x. And over there, K2x. So K1x plus of K2x is equals to K equivalent x. K equivalent x. Why? Because here force is same. What is our force formula? F is always equals to Kx. Forces are different, but displacement must and should be same. Then displacement we have taken same. X again get cancelled. Left out is what? 1 upon, K equivalent is equals to K1 plus of K2, so on. This equation should be used if we found that the springs are connected in what? Parallel. And how we are saying they are connected in parallel? Based on what? The displacement. Are yes or no? So if displacement is same, then we are going to call that system as what? Connected in parallel. If what? Force is same, then we are going to call that as the system is connected in what? Series. I got the point? Okay. So for parallel and for series. Okay, let us move to some example. We will understand the topic now. Okay, shall I? Just tell me by raising the hand which one is connected in series and which one is connected in what? Parallel. Okay, if two or more springs are being connected in this format like this, end-to-end connection, series or parallel? Series, very good. If they are connected like this, series or parallel? Parallel, okay. So if they are connected like this, here is one spring, here is one spring. Now tell me, this one is connected series or parallel? How many say series? Just raise the hand, beta. Awaaz mat karo. Series, parallel. Okay, what is our basic funda to recognize what is connected in series and what is connected in parallel? If the displacement is same, then it is parallel. If the force is same, then what? Law, okay, K chahiye na tumko. So consider this one is what K1 and this one is what K2. Both are different. Okay, maybe this one is 100, maybe this one is 200. Mass will be always same. Mass to change nahi hoga na. Okay, so K1, let's say smaller or bigger, whatever you want to consider, but K1 and K2 are not equal. Now tell me, it is connected in series or parallel? Even though if it is same, क्या कर लेगा? Series होगा, parallel होगा? Parallel, yes, very good. Parallel होगा. Why? The main reason is, now let us try to understand those who haven't got this point, why I am saying that it is what? Parallel. Okay, so now, if I try to apply the external force in this direction, okay, consider the natural length of this spring is 2 meter, this one is also 2 meter, okay. So, natural length is 2 meter, natural length of this spring is also 2 meter. So, we are considering with respect to what? Natural length, okay. I displayed to a distance of 1 meter. That means, from here to here, I displayed how much? 1 meter, okay. If I displayed 1 meter, how much this spring get compressed? Obviously 1 meter. How much this spring get expanded? 1 meter. So can I say this expansion of this spring and compression of this spring, that is what? Same. That means if displacement is same between two springs, then it is called as what? Parallel. I got my point. Okay. Similarly, we can have the setup like this also. ये लिखना नहीं है बेटा, सुनते जाओ first. Okay, then what they ask generally, what they ask means find out the amount of force. Find out the amount of force. What is our formula? F is equals to what? K equivalent into X. Okay, what will be the K equivalent here? K1 plus K2. So K equivalent over here is K1 plus of K2. Why it is connected in what? Parallel. If I say this one is 100 and this one is 200, or if I say this one is 100, this one is 100. Okay. So 100 plus of 100, that is what? 200. All you need to substitute here, F is equals to 200 into displacement is 1. That means force is what? 200. Are got my point? समझ में आया कैसे करना है? Okay. Similarly, consider one more spring or the block is been connected like this. So this one is your mass here and here. Then one more is here. Then one more is here. Series parallel. ओके K1 K2 ले ले रहे भाई, K1 K2 K3, तो K के पीछे क्यों पड़ा रहे? ओके K1 K2 K3 K4 so on, 4 springs are been connected. Can I say these two are connected in series or parallel? Obviously they are in parallel. These two are connected in what? Series or parallel? Parallel. करना कैसा है? Now listen to me. K1 K2. Okay, so K1 plus K2, you will be getting K equivalent. So let's say K1 plus K2, K equivalent 1 is equals to K1 plus of K2. ऐसे नहीं जाना है. One side first, then jump to the next side. Okay. Then next, K1 plus, K3 plus K4. So let's say K equivalent 2 of this one is K3 plus of K4. I got my point. So K3 plus K4 is nothing but K equivalent 2. Okay. K equivalent 1 and K equivalent 2. That means if I change this value from here to here like this, now this one will be mass and this one will be the second spring. This one is your K equivalent 2 and this one is your K equivalent 1. ऐसे समझो. Okay, two springs are connected in parallel. These two are connected in what? Parallel. I got my point. So we have found the K equivalent. Okay, let's say this one is 100, this one is all are 100. All are 100, consider. So 100 plus of this 100, 200. 100 plus of this 100, again 200. Are you yes or no? Okay, 200 plus of this 200, that means 400. Are you got my point? Okay, still don't write please. ये सुनने वाला क्लास है सिर्फ. Okay, now listen to me. If the setup is like this, here is one spring, then one more spring, then one more spring, then again over here is one block, then over here is one spring, two spring, again over here like this, one more is also connected over here. Okay. Now again K1, K2 all are different, all are same. Whatever you want to take, you can take K1, K2, K3, K4, K5, K6. This one is your K7, K8, K9, K10, K11. How many springs are there? 11 springs are there. Now how to do this? First complete this line. Okay, K equivalent, this K1, K2, K3 connected in series or parallel? Series. Are yes or no? Series means you need to what? 1 upon K equivalent is equals to 1 upon K1 plus 1 upon K2 plus 1 upon K3 so on. Are yes or no? Iska K equivalent nikalo. So consider for this one is K equivalent 1. Okay, all are connected in what? Series. Are yes or no? Again this one all are connected in what? Series. Again consider K 1 upon K equivalent is equals to 1 upon K1 plus 1 upon K2 plus 1 upon K3. I got my point. So let's say this is your K equivalent 2. Okay, K equivalent 1 and K equivalent 2 are connected in series or parallel? Again parallel. Yes, very good. So these two are connected in what? Series. These two are connected in what? Series. This one is having a single. That means K equivalent 3, K equivalent 4 and this K11. All are connected in what? Parallel. These two are K equivalent 1 and K equivalent 2 are connected in what? Parallel. So all you need to do what? You should recognize and calculate what? K equivalent. Okay, then substitute in what? Equation. Are you got my point? Either the system is being placed like this also. The system can also be placed in with what? MG. That means vertical systems. Maybe the system is connected like this. Here is one spring, here is one spring. Both are connected on a single platform with massless. This one will be massless. Okay. One more will be connected over here. One more will be connected over here. One more will be connected over here. Again, there will be one platform. Okay. Again, this one is connected over here. This one is connected over here. Then this one is connected to a single spring like this mass. Okay. Now they will tell you that this find out the what mean position of this one. They can ask you find out the mean position. This one is K1, K2, so on. K1, K2, K3, K4, K5, K6, K7, K8, so on. कितने भी लगा लो रे. Okay. Now, K1 and K2, series or parallel? Parallel. That means K equivalent 1. So, from here, we got K equivalent 1. Because of what? Parallel. Are yes or no? Okay. Then, K3, K4, K5, all are connected in what? Parallel. Then I will be getting what? K equivalent 2. Are yes or no? Similarly, K6 and K7 again parallel. So, consider this as K equivalent 3. Okay. Obviously, this K8. K8. Now, all will be connected in series ना. ऐसा बन जाएगा. Here is one, then one, then one, then only one with what mass? So, this one will be K equivalent 1. This one will be K equivalent 2. This one will be K equivalent 3. This one will be K equivalent, K8. Very good. Not very good, thank you. Okay, K equivalent 1, K equivalent 2, K equivalent 3, all will be connected. All are connected in what? Series. Or for that final K equivalent, let's say 1 upon K final equivalent will be equal to 1 upon K equivalent 1 plus of 1 upon K equivalent 2 plus of 1 upon K equivalent 3 plus of K11. Sorry, 1 upon K11. Okay. you will be finding this one. Okay, now you got K final equivalent. You got my point? They ask you to find what? Mean position. At mean position, what is our formula? Kx should be equal to what? mg. Kx should be equal to what? mg. Now in terms of K, all you need to substitute K final equivalent into x, which is equals to mg. Are yes or no? So x is nothing but mg upon K final equivalent. This is what? The mean position. I got my point? They can ask you find out the acceleration also. इसको थोड़ा सा नीचे लेके जाओ, छोड़ दो. Obviously it will be going in the upward direction. If it is going in the upward direction, then the equation will be Kf equivalent minus of mg. Very good. Which is equals to what? ma. Acceleration will be in the upward direction. Are yes or no? They can frame the question like this also. There will be a triangular slope inclined with an theta. Over here, 2 springs. Okay, then there will be one platform. Over here are 2 springs again. Okay, one more platform. It is been connected with some mass. Are yes or no? Over here, in this one is having the mass m. Then नीचे क्या जाएगा बेटा? mg जाएगा. Over here will be mg sine of theta. Are yes or no? Again, how to find the mean position? Are yes or no? Substitute and find the what? K equivalent first. Then K equivalent into x is equals to this times can I rewrite mg sine of theta. Are yes or no? So K equivalent over there is equals to mg sine theta. Okay, नहीं दिख रहा क्या उधर कैमरा में? Okay. So over here, from the mean position, over here I will be writing K equivalent x is equals to mg of sine theta. Or yes, if that particular thing is being dragged in the downward direction, then released, obviously it will be accelerating in the upward direction in this direction. Again, you know the basic funda. और क्या तो टाइम पास करेंगे क्या? Okay, write on. Then let us write the next topic, that is what? Cutting of spring. Okay.